A very warm welcome, my dear students. Today we will be solving paper 4-1 from 0625 code, and it's the October-November 2025 series. Let's quickly jump to question 1. It says a train travels with a constant velocity of 56 meters per second on a horizontal track. The mass of the train is 440,000 kg. As for the A part, it states the difference between the velocity of the train and its speed. See, velocity is a vector quantity. On the other hand, speed is a scalar quantity. So, velocity being a vector will have a magnitude and a direction associated with it. Speed being a scalar will only have a magnitude. So 56 meters per second is the speed, but when I say it's 56 meters per second on a horizontal track, that means that is the velocity because it is also telling us the direction. In the B part, it says calculate the kinetic energy stored in the moving train. So we know in order to calculate kinetic energy, we use the formula 1 by 2 times the mass times the velocity square. So we would just directly substitute the values in over here. So 1 by 2 into the mass, which is 440,000, and we also have the velocity, which is 56 meters per second. So 440 seconds, so 440 kgs times 56 square. This is the calculation that we are doing over here, and it simply comes out to be 6.9 into 10 to the power 8 joules. There can be a little bit of rounding off if you want to. Otherwise, you can leave your answer in whatever way you get it. But yes, I do suggest that you write your answers in the standard form in order to get proper marks. For C1, it says that the train has a uniform deceleration of 1.2 meters per second square. Calculate the constant braking force which brings the train to rest. So we already know that if you want to calculate the force, we have to do mass times acceleration. The mass is already given to us, which is 440,000, and the deceleration is nothing but negative acceleration is given to us as 1.2. So 440,000 times 1.2, which comes out to be 5.3 into 10 to the power 5 newtons. That's a direct calculation for force. Again, do not forget to write the unit. The unit for force is Newton. Moving on to the next part, it says calculate the distance traveled by the train as it comes to rest. We already calculated the braking force over here, and we also know that the work done is equal to the energy transferred. And on the previous page, I had also calculated the energy that was required, or the energy with which your train was moving. So it was moving with an energy of 6.9 into 10 to the power 8 joules. So same amount of energy or same amount of work has to be done in order to stop it. So our work done or the energy transferred is 6.9 into 10 to the power 8. We also know that the work done is nothing but force times the displacement, and the force that we calculated in the previous part was 5.3 into 10 to the power 5 newtons. So 6.9 into 10 to the power 8 divided by 5.3 into 10 to the power 5 newtons will give me the distance. So this distance simply comes out to be 1. So this distance simply comes out to be 1,300 in meters. If you want to put it in kilometers, you just divide it by 1,000, so it would be 1.3 kilometers. Now let's quickly move on to question number 2. So for question number 2, they have given us some information about the planet Mars, which is mass, the gravitational field strength, the average density, and firstly we have to define the gravitational field strength. So gravitational field strength is basically nothing but it is the force acting on a unit mass in a gravitational field. Now let's look at B1. There's an object of weight 42 newtons at the surface of Earth. We have to find the weight of the object at the surface of Mars. So we know the equation weight is equal to mass times the gravitational strength. So the weight on Earth is 42 newtons. So using this equation, we can calculate the mass on Earth. So the gravitational field strength on Earth should be taken as 9.8, or if you want you may take it as 9.81 as well. And on calculating this, the mass simply comes out to be 4.3 kgs. Now whatever is the mass on Earth, same would be the mass on Jupiter or Mars, whatever planet they are asking for, the mass would always remain the same because mass never changes. So the mass on Mars is also 4.3 kgs. Now if I want to calculate the weight on Mars, I can do mg, and again over here for my mass I would take it as 4.3 times the gravitational field strength on the surface of Mars is given to us as 3.7 Newton per kg in the question itself. So 4.3 times 3.7, and this would give me the weight as 16 newtons. Therefore, the weight on Mars is 16 newtons. Further, we have to find out the volume of Mars. Over here in the question, they gave us the mass and density, so we can calculate the volume by using the formula. Volume would be equal to the mass divided by density. It's just a rearrangement of the density equation. So over here, the mass has been given as 6.4 into 10 to the power 23 kgs. And the density has been given to us as 3900 kgs per meter cube. So we simply divide these two and we get the volume as 1.6 into 10 to the power 20 meter cube. Again, units are very important. Further, for C part, it says figure 2.1 shows a space buggy which is tested on Earth. The buggy is traveling at a constant speed in a straight line and the driving force on the buggy is 30 newtons. Draw and label one arrow on this figure to show the size and direction of the resistive force on the buggy. So they said that it is moving with a constant speed. Constant speed means that there is no acceleration, or in other terms, the forces are balanced. See, the resistive forces always act opposite to the direction of the driving force. So therefore, the resistive force will act towards right, since the driving force is acting towards left, and magnitude has to be equal to that of the driving force. So this is also 30 newtons. Why? Because there's no acceleration since it is moving with a constant speed. For the second part, air resistance on Mars is less than the air resistance on Earth. The same driving force, 30 newtons, is exerted on the buggy on Mars. State the effect this has on the resultant force on the buggy on Mars. See, if the resistive force is less on the surface of Mars, therefore that means that the resultant force on the surface of Mars would be higher. Why higher? Because our resistive forces are less. Then further we have to state the relationship between the resistive forces, driving force and the resultant force. So we already know that the resultant force, in this situation, the previous one where we have drawn the arrow, the resultant force was 0 because the object was told to move with a constant speed. But here in general, if the resistive force and the driving forces are not balanced, let's start talking about question number 3. Figure 3.1 shows a simplified diagram of a solar cell. Describe the energy transfer in the solar cell. So in the solar cell, the sun's energy, which is the light and the heat energy, is falling on the cell, which is being converted into the electrical energy. So the energy transfer that we are talking about is simply the light energy going into the electrical energy. Or you could also say that it's the electromagnetic energy which is going into the electrical energy in the cell. That's the transformation taking place inside the solar cell. Then suggest how the black coating allows the solar cell to transfer more energy. See, we already know that black is a good absorber. In fact, black is one of the best absorbers. Because black is a good absorber, therefore it will absorb maximum amount of heat and it will hardly reflect any heat. So because it is a good absorber, it absorbs maximum amount of heat and it is able to allow that heat to flow through it via conduction, because the black coating is a good absorber. So there is conduction taking place in here. Moving on to C1, we have 0.72 kilowatt of light that is incident on the solar cell. The cell has an efficiency of 75%. Calculate the output power of the cell. Now we already know that the efficiency is the power output by the power input times 100 if it has been expressed in percentage. So we can directly just do the substitution here. The efficiency is given to us as 75 and the output power is what we are trying to calculate, and the input power has been given to us as 0.72 kilowatt and it's into 100 because it is in percentage. We rearrange this equation to calculate the power output, and the power output from here comes out to be 0.54 kilowatts. A small shortcut to check your answer is that your power output always has to be less than the power input as long as the efficiency is less than 100%. Even if it is 100%, then your power output will be equal to the power input. Your power output can never be greater than the power input. Then for the second part, it states it is asking you to calculate this meaning, or it is asking you to find out the meaning of the term kilowatt per hour. Kilowatt per hour simply means that if there is a device that uses 1 kilowatt of power, then it is using 1 kilowatt of power in 1 hour. So 1 kilowatt hour simply means that the device or your object, whatever you're using, is using 1 kilowatt of power in 1 hour. For the third part, energy is produced by each solar cell for an average of 6 hours per day. A household uses approximately 7,400 kilowatt hours of electrical energy per year. Calculate the number of cells that are needed to produce energy for one household. Give your answer as a whole number of cells. Okay. So we need 7,400 kilowatts of energy per year. Let us calculate the energy required in 1 day. So energy required for one household in 1 day. So for that, we simply have to take the total power for the year and divide it by the number of days in the year. So in 1 year, we would generally take the number of days as 365. So 7,400 divided by 365. This will give me the energy in 1 day. Now, this is the amount of energy that is required in 1 day, and at the top we have calculated the output power to be 0.4 kilowatt. So the energy produced by one cell in 1 day will be equal to the energy of one cell times 6 hours, because we are using it for, like, it can give us energy for 6 hours. So we have the power multiplied by the time. So 0.54 times 6. This much energy is produced by one cell in 1 day. So now if I want to calculate the number of cells would be the total energy required in 1 day divided by the energy output of one cell. So we would simply do 7,400 divided by 365. This is the energy required in 1 day, and then this has to be further divided by 0.54 times 6. This will give me the number of cells. The number of cells by doing this calculation comes out to be 6.25 cells, but then obviously we cannot have 6.5 cells, so the whole number to which we round it off has to be 7. So there are 7 cells required in order to produce energy for one household. Further, moving on to question, let's start talking about question number 4. So question number 4a says that a 12 volt 50 watt Immersion heater is used to heat 0.15 kg of water in a beaker. The water is initially at room temperature of 20 degrees Celsius. Specific heat capacity of water is 4200 joules per kg degree Celsius. Calculate the energy supplied to raise the temperature of the water from 20 degrees Celsius to 58 degrees Celsius. See, in order to calculate the energy, we know that energy would be equal to mass times the specific heat capacity times the change in temperature. So the mass of water given over here is 0.15 kgs. The specific heat capacity for water is 4200 and the change in temperature would be 58 degrees minus 20 degrees, which would give me a change in temperature of 38 degrees Celsius. On doing the calculation, this energy comes out to be 23,940, and which is approximately equal to 24,000 joules. For the B part, we have to describe how the temperature of the point X on each rod changes after the rods are placed in the beaker. So one of the rods is made up of metal and the other rod is made up of plastic. So firstly, we understand that the temperature on the metal rod would increase faster because the metal rod is a better conductor of heat. So because it has free electrons, therefore it allows the transfer of heat energy by conduction. So temperature in the metal rod will increase faster because it's a good conductor and it has free electrons, due to which it allows the transfer of heat energy by conduction. Let's talk about question number 5 now. A dolphin communicates with other dolphins underwater by emitting sounds in the range 7 to 15 kilohertz. State the value of the speed of sound in air and state how the speed of sound in water differs from the speed of sound in air. So speed of sound in air can be anywhere between 335 to 340 meters per second. So let's just say that it is 340 meters per second. Speed of sound in water is definitely more than the speed of sound in air. So speed of sound we can say is faster in water. In fact, in liquids it is faster, and in solids the speed of sound is the maximum, it's the fastest. Then for the B part, say it and explain if humans with normal hearing can hear all the sounds emitted by the dolphin. So see, the normal human range, or if you talk about the hearing range for a normal human being, which is what we also call as the audible range, it is between 20 hertz to 20 kilohertz. So since the sounds that are emitted by dolphins also lie between this range of 20 hertz to 20 kilohertz, therefore the statement is correct. So yes, we can say that the answer or the statement here we can say is that it is yes. The humans with normal hearing can hear all the sounds emitted by the dolphin because it lies in the normal human range, or because it lies between the normal hearing range for human beings. Now for part C, we have to complete table 5.1 to describe the differences in loudness and pitch of the two different dolphin sounds. So for frequency 14 kilohertz, the amplitude is large, so the loudness would also be large, because large amplitude means that the loudness is large. And if you talk about the pitch is directly proportional to the frequency. Since 14 is greater than 8, therefore the pitch here is also high. For the second dolphin, which has a frequency of 8 kilohertz and amplitude that is small, its loudness would also be less, or you can say it would be a soft sound or a quiet sound, or you could say that it would be just having less loudness. For the pitch would also be less, or pitch would also be low because because of its frequency being low. Pitch is directly proportional to the frequency and loudness is directly proportional to the amplitude. Sound waves are made up of vibrating particles which produce compressions and rarefactions. A compression is a region of high pressure and a rarefaction is a region of low pressure. The sound waves, they travel parallel to the direction of vibrations since they are longitudinal waves. So we are done with the first 5 questions. For the next 5 questions, watch out for the next part of the video that's coming up soon. I hope you understood all these questions, and if you understood them, please do not forget to subscribe to my channel. Thank you for watching.